So I know, first of all, that a lot of you are probably pretty tired. It's hot, and it's been a really long day. So I'll try to make this as quick, efficient, and hopefully engaging as I possibly can. So yeah, today, and thanks to Gnosis and everyone doing DappCon, I think this is it was a really great event. Cool. So this presentation, I'd like to just go over a concept, something I thought would be a little controversial, which is Ethereum without ZK. So there's always so much discussion around ZK that I'd like to actually try to imagine a world where we just don't use it that much. And I think that this should hopefully describe maybe an alternative position in the community that is something maybe not so considered and something that might help us actually use ZK better or more effectively, in developing all these different technologies that we're doing right now. So the first thing is I do love ZK. I think it's an amazing thing, and even though I put a very controversial title, I do love it. I think it's an amazing primitive, the fact that human beings can produce these kinds of succinct proofs, mathematical proofs, and create this kind of reality that we have with crypto. But there's a few caveats to using it. So the thing is, we love it. It's very, very useful. It's getting better all the time. There's significant improvements all the time. We use it across a ton of architecture. But there's a few things that kind of suck. And I think that the more we're open about it, the better we can apply all of this in reality. So some issues. So basically, and don't mind the very bottom, it's sort of supposed to say hard to beat optimistic soft confirmations. But yeah, so ZK verifying and proving is both too late in the process and also it's really, really expensive. And one thing that maybe we don't consider so much in a global context is just exactly how the internet is wired and why doing things in the way that we're doing them now kind of really sucks. So some things to bring up. Global ping times are not great. It's very hard to basically create a world where we have everything interconnected and it sort of feels real time. We're just not really going to get there, which means that things need to be done ahead of time, which means all kinds of different assumptions that are definitely not ZK assumptions. So global ping times really make using ZK proving kind of difficult. As well, there'll be latency on markets. There'll be contention issues that need to be worked out before you actually do things in proving. As well, even if we have FPGAs and ASICs, which we will have pretty soon, and Justin Drake is like super excited and everyone's so happy, we'll have it, but bare metal racks are not really first-class citizens, at least in the way that the internet's wired, and so there's going to be tons of latency even placing devices like that around computing in general and where it is. As well, we have a hard enough time managing non-ZK nodes. So just literally running blockchain nodes is a giant PITA that is so awful that if you only could speak with DevOps guys, they would tell you wild, wild things. And basically, we're in this sort of weird space too where optimistic soft confirmations, right? Things that we can just kind of do ahead of time because we know things are true because, quite frankly, a lot of the stuff we're doing with blockchain is very, very simple. They're just really, really fast and really, really great for a lot of different reasons. So soft confirmations are like something that's really, really hard to beat, especially with the UX that we're really looking for. So when you're thinking about like a typical sort of pipeline, you have the transaction going to builders, you'll have sequencers, and this is, again, the ideal situation for rollups. So you'll have like a sequencer, hopefully a decentralized one. You'll have rollups, you'll have different kinds of bridges going back to Ethereum, optimistic and ZK. And you can see that it's already quite a pipeline, and there's already going to be quite a bit of latency just within this pipeline alone, and this is a pretty simple one. This isn't even considering multiple different builders or other kinds of things like that. Like it can get very, very complex. And so basically you're going to be fighting, as I was describing before, global ping times, and if you really want to make a global system where you have you're working out global state contention, then you're going to be dealing with overhead of like at least a few hundred milliseconds if you're actually going around the entire world. And that really sucks if you want to have this sort of amazing ZK-proved system where everything is kind of interoperating and sending its ZK proofs and verifying them all over the place. So this really just complicates everything, because this is just going to create all kinds of back and forth latency and overhead between each piece. And it's really because you're fighting physics and the speed of light, and you're fighting all kinds of submarine cable issues and all sorts of things. And if you want to make Ethereum really global, and you want to make Ethereum really something that really does run and is protected and being built in all places around the world, then unfortunately you're going to have to cope with latency, and unfortunately that means a lot of interoperation between all these different pieces. So complexity and overhead is basically a huge challenge. Even if we had magical ZK chip in our hand that did everything, it's still an enormous challenge. There's so much that you have to do ahead of time even to get there. And Fuel, even though we're more known for actually doing the first optimistic rollup, and that we focus on optimistic rollups as our technique, we actually use ZK a lot as a product. Like we use SP1, we use RISC-0, we use all kinds of different ZK products because we're more agnostic. And I can tell you firsthand that like it's cool, it's really cool, but it's not there yet. It's very difficult to use right now, especially in production. It's getting there, but it's difficult. So there's this overhead issue, there's a complexity issue. Custom chips are really hard to build economically. They're hard to service too. And ZK is very hard to make economical for something that usually gets overlooked, which is very small chains. So, one project, one chain, maybe they have their own user group. They'd like to interoperate with everything, but they don't want to pay an enormous proving bill. It's really, really expensive to run. They have to cut costs everywhere they can, and this is really not worth it for a lot of small projects that have a lot of volume. So, why should they pay this proving cost just to prove to Ethereum that what they're doing is valid? Which, by the way, if you just run a node for a lot less money, you can show that it's just valid. But you just can't really show Ethereum very well that it's valid. So what tools do we have outside of ZK? And by the way, this is something relevant to both ZK projects and non-ZK projects, because it's also relevant to what you do ahead of the ZK itself. What assumptions or what things or tools are you using either ahead of ZK proving or without ZK proving at all? So some typical core mechanisms that basically engineers have thought up over time is honest majority assumption gadgets, honest minority assumption gadgets, hardware-based attestations, bonded cryptographic attestations, and social slashing. So not totally in specific order in any way here, but just to say these are some varieties of mechanism that we have to construct things that allow us to work through building these kind of state transition machines. And so, you have the typical like layer 1 designs, you have side chains, you have committees, you have multisigs, and that's in the honest majority category. Then you have a very special odd category, which is the honest minority assumption gadgets. And these ones are really actually, it's a very small group currently. It's just Fuel v1 and maybe one or two other rollups. Bartek's in the room. He'll probably be able to clarify which ones really meet an honest minority assumption. And then as well, there's this gadget I released recently called, I just call it fast finality optimistic rollups. So you can read that on Ethereum research. And that describes a mechanism to build fast finality optimistic rollups such that optimism, arbitrum, everything can basically, if everything works well, can drop their finality window down to 1 Ethereum block or less. So basically, alleviating that 7-day window that's very, very annoying while retaining the honest minority assumption. Then you have hardware-based attestations, which kind of got a bad rap over time, but they're actually super important. So like Intel SGX got a very bad rap, a lot of bad things about it. But when you're really thinking about building these really complex provers and complex systems, like at some point you might need to level with yourself and be like, hey, if I had something like SGX that really worked, and that gave me a really good cryptographic attestation from this known hardware device, that's pretty great. It's not ZK, but it's actually very, very good in comparison, especially when you consider all the overhead. Sign bonded light client proofs and other things are really interesting. There's a lot of mechanism design there. And then you have some interesting like kind of social slashing and governance mechanisms you can see with things like eigenlayer and Ethereum in the worst cases where we have like just tyranny on Ethereum itself. So these are the mechanisms we actually have, and these mechanisms are actually pretty amazing. They're not going to give you everything. They're not going to give you a single succinct mathematical proof that things are true, but they are going to give you an incredible tool set to build some really, really great things. And if you can actually get things down to an honest minority assumption, that's pretty great for most projects, and it's virtually almost free if you can actually manage it. And the cost is very, very low. So what would Ethereum look like if we just forgot about ZK for a second? We just only had these other mechanisms. So basically, optimistic rollups would become commonplace as the primary rollup format. Cross-chain atomic execution would be done through builder networks and attestations. So builders would be able to basically build on different chains, but they can see the state of it, and they would attest, and then you would basically get some kind of cross-chain atomic processing that would sort of make all the existing optimistic rollups feel like they're kind of one, at least to a user. You would have assumption-based sequencers, so things like Tendermint and other things would be used to help sequence transactions. As well, there's also base sequencing. That's something people are discussing. And then you would be using minority and majority and social slashing assumptions everywhere in terms of the mechanism design. So, and probably with different levels of combination. As well, intents, which ANOMA is kind of known as like one of the major intent projects. Intents would be used everywhere, basically to create a different kind of user experience that you're not going to get if you're just trying to make transactions all the time. But instead, you're kind of settling what you want outside of some of these chains. Staking and, let's just say restaking, sorry. Staking and restaking can be done on primary operators as well. So when you actually have all of this, one of the biggest benefits of not using ZK is that it creates risk. And unfortunately, for human beings, risk is such an incredible provider of yield. And when you remove all of the fun of the risk, you also remove all of the opportunities for yield. And so a really big one that is sort of not really listed here, but is something that I think is really, really cool, is that when you step away from trying to get absolute truth, you actually step into a different reality where, well, how much are you willing to risk? And with Ethereum, you could put billions of dollars on it. It's got like $90 billion of economic security. Like, that's pretty great. And even if that whole 90 billion was corrupted tomorrow, like, we would as a community sort of socially fork and probably fix it. So like, this is a pretty amazing effort in the sense that Ethereum is running on this majority assumption, and we just kind of have this social contract, at least as a community. So basically, what's really wild about thinking about Ethereum without ZK for a second is just that we're getting to a place where, well, it's creating all these kinds of new risk-oriented opportunities that you would remove if everything was just perfectly mathematical. And I think that humans actually prefer this, and the markets probably prefer this, over just making everything risk-free at tremendous cost. And so when you look at like the pipeline again, you can see that there's different assumptions that are going to have to underpin different areas of rollups themselves. And this is a very stacked assumption in general for security. So, as opposed to just like a single monolithic chain that has only one assumption that you're really going with, yes, you're sort of stacking them up over time. But at each one of these layers, you're actually creating a tremendous point of value creation that I think is really, really interesting. And remembering that we don't need to rebuild honest majority chains all the time. We have rollups. We have Ethereum to prove things, which means you can have honest minority assumptions, and you can create all these kinds of bonding and staking and slashing criteria with those, but with much better guarantees on security. So it's really actually a very fruitful universe if you look at Ethereum without ZK. And I think that that's sort of a different angle. So again, the benefits with no ZK are that you just don't have this giant overhead that we're always thinking about all the time. And it is getting better every day, but it's still just an enormous overhead. And unfortunately, I'll be the the uncomfortable customer in the room being like, I don't like this yet. It's very, very expensive. But it'll progress and get there over time, but maybe this is a little bit of a reality shift for at least Ethereum itself. So again, no proving overhead as well. Cross-chain atomic execution can be done by attestation, or it can be done by even honest minority bridges. As well, there's just way more opportunity for cryptoeconomic risk-taking, which is awesome. And that proving times are no longer an issue, because the second the computer validates it's true, then you're either going to build an attestation out of it, you're going to vote on it, you're going to progress it. And remember that with all the latency that ZK will have, you'll still need to do things ahead of time anyway. So some of these things will still need to be there. And as well, one last thing that we don't really talk about is that there's just no complex overhead on the auditing surface level. So you're really only doing the transactional level, and that's it. So there is some pretty awesome benefits. Some downsides of no ZK are, of course, you've introduced new assumptions and new bonding. You've introduced more bridging and interoperation risk. And as well, there's challenge windows and gadgets that we'll need to overcome. But even with my fast finality gadget that I released as well, and I'll release a part 2 of that gadget, there is ways to actually overcome the reliability of those things, if you know what I'm talking about. And that'll be a very exciting post that I'll do later. So what does this look like in the end? At least for Fuel and what we think of ZK is that we take a position of pragmatism with ZK. So call it ZK pragmatism. So there's certain areas in our build that we really like using ZK and that it's really, really good at. So compressing data and witness information, fraud-proving enforcement in the pessimistic cases, Verkle trees and state minimization, proving low-throughput rollups is definitely a possibility. Unfortunately for Fuel, which is a high-throughput rollup, it's going to be a long time, I think, until we really see that to be very, very efficient. And then as well, predicates, which are something unique to what Fuel does and what certain ecosystems do, which allow for monotonic processing in sort of a massively parallel way. These are great moments for ZK, and we definitely want to use them for those. What we don't like it for is interoperation between rollups and proving high throughput, low value rollups. These are very tricky in terms of proving itself. So, of course, always open to reevaluate as the angry ZK customer in the room. And FPGAs and ASICs will reevaluate those as they come out and reevaluate all kinds of ZK in the high throughput setting. But for us, we're definitely more on the pragmatist side when it comes to ZK. We love it. We love all the different ideas that can come from it. And we use it in our designs all the time. But we just don't use it to prove everything because, quite frankly, for most of our users, they just wouldn't want to pay for it. And even if it's for interoperation or security, they still wouldn't want to pay for it. And they wouldn't even want to lose the opportunity to generate all the yield off the risk of producing a new chain anyway. So anyway, a bit of a controversial, odd presentation, but hopefully that was interesting. And yeah, thanks everyone.
Thank you, Nick. Good to hear some real talk about ZK proofs. We have a few minutes for questions for Nick, if there's any in the crowd.
Thanks for the presentation. I think I personally share with you most of the comments, just not the conclusion. Okay. So a question for you. Assuming we lived in a world without zero knowledge, okay? Yeah. How would you see challenges working for systems like, EigenLayer or similar, where basically at the end of the day you need a challenge to be able to solve disputes, as with many of the other approaches we are saying? Also, if we decide to exclude SGX and other T-based attestations.
Yeah. So I think that so Ethereum provides us the most incredible platform to witness state transitional machines that we've ever created. So Ethereum is the best platform ever that humans have created to adjudicate something, computational at least. So, so in a sense, Ethereum provides us with an amazing platform to adjudicate. But I think that the best assumptions that every mechanism should work over is probably an honest minority assumption, meaning that any one particular party on planet Earth, if they run the machine, can challenge that there's something invalid. And I think that when you get different designs down to that level, it just becomes such an interesting world, because you could have, like, out of a validator set of like 300 people, you could have one person who's just maniacal who can defend the entire system, even outside of the cryptoeconomic like criteria for like a rational actor. So I think that like the IVG games we have that are between like Bold and what Optimism is doing with Canon, like those mechanisms are fine to adjudicate computation on Ethereum. They're not really great, and quite frankly, we prefer using ZK to do those fraud proofs because it just makes more sense. But I think that the most interesting world that we haven't lived in yet is building everything with honest minority assumptions around Ethereum. And I think that that's actually a very, very crazy world. Like, there's no honest minority bridges, really. There's no challenge-based honest minority gadgets being used all in different kinds of ways. And what I don't like about Eigenlayer is it assumes majority assumptions too much. And for me, my favorite designs are to just assume that Ethereum is your only honest majority assumption, and then build off of that with honest minority assumptions. And to me, that garners such a high level of security. Even we've seen the trust in Arbitrum and Optimism to produce these systems and gain the TVL that they have, that I think that for most cases on planet Earth, for most human beings, building your chain with an honest minority assumption is like probably one of the best things you can do. And it's not exciting, it's not sexy like ZK would be if it was all magical ZK, but I think that that narrows down the security profile and the risk profile so low that like it's really worth it if you can do it. So with Fuel and some of the gadgets we'll be producing code for, you'll see that we can actually achieve really great fast finality properties while retaining a minority assumption and a permissionless validator set, and building that off of Ethereum, and showing that it produces really great, as I was mentioning, opportunities for risk, which creates great opportunities for yield. And I think that we shouldn't ever understate that, especially looking at the success of staked ETH and the success of some of these designs that we have in the space. So that would be my preferred world, is that everything's an honest minority assumption, if that makes sense. Except for Ethereum. That needs to be a majority, probably. Yeah.
Thank you so much, Nick.
Thanks, everyone.
We'll get started in about 1 minute.